All right, let's talk about AI's next big leap. And I'm not just talking about another cool picture you can make with a text prompt. We're going way deeper than that. We're going to dive into some brilliant new research that's making these AI image tools, well, smarter, faster, and way more precise than we ever imagined. You know the feeling, right? It's that moment when you type in a few words, something wild like an astronaut riding a horse on the moon, and boom, seconds later, there it is, an image. It honestly feels like magic. And let's be real, these text-to-image models have totally changed the game for creativity. But, that initial wow moment, it can come with some real headaches. Like, what if you need to change an image's style, but you can't share sensitive data? Or you want to restore a blurry photo perfectly? Or maybe you just want to edit one tiny part of an image without spending hours masking it out by hand. And what if you need all that? Like right now, not in a few minutes? Well, these aren't just hypotheticals. These are the exact problems that researchers are tackling as we speak. Okay, so let's get into it. We're going to look at four really incredible solutions that are taking AI way beyond just a simple text prompt. These are the things solving some of the biggest frustrations with image generation today. So first up, let's talk about privacy and really just flexibility. Imagine this. You want to turn a medical sketch into a photorealistic image. Okay, you need to train a model for that. Cool. Now you want to turn a daytime photo into a nighttime scene. Well, you need a whole other model for that. It's just so rigid and inefficient, and it becomes a massive problem when you're dealing with data you can't just share with everyone. And here's where we see this huge conceptual jump. The old way, it's like building a separate bridge for every single trip you want to take. One bridge from Sketch City to Photo Town, another one from Day Valley to Night Mountain. It's just so rigid. But the new way, this method called DDR-IBS, is totally different. Instead of building all those one-off bridges, what if each domain just learned how to connect to one central universal hub, like a Grand Central Station for images? So how does this hub actually work? It's actually a really elegant two-step dance. First, a model that only knows about sketches takes your drawing and translates it into this universal abstract language. You can just think of it as a mathematical blueprint of the image's core ideas. This is what we call the latent space. Then a totally separate model, one that only knows about photos, just grabs that blueprint and builds a new photo from it. And here's the magic trick. The sketch model and the photo model never, ever have to see each other's data. They just talk through the hub. I mean, the impact of this is just huge. Think about fields like medicine, where patient data is incredibly sensitive and absolutely cannot be shared. This is a total game changer. You could have hospitals all over the world collaborating to build these powerful diagnostic tools, all without a single private patient scan ever leaving its own secure server. Now that is the power of this kind of thing. All right, let's tackle the next big challenge, fixing flawed images. You'd think AI would be the perfect tool for restoring an old photograph or maybe sharpening a blurry image, right? But the truth is, it can really struggle to get clean, consistent results. So what's going on here is what researchers call an inverse problem. Basically, you have the final, messy result. The blurry photo. And you're asking the AI to work backwards and figure out what the clean, original picture looked like. It's kind of like trying to unbake a cake. It's tricky. The real issue is that there isn't just one right answer. There could be lots of possible unbaked versions of that blurry photo. So standard AI methods can get a little confused. And that's when you get these noisy results or weird digital artifacts, especially right at the edges where the fixed part is supposed to blend with the original. So the fix is actually pretty clever. You have to force the AI to respect the facts, the ground truth of the image. These new algorithms do something called enforcing data consistency. It's basically like telling the AI, hey, look, go ahead and be creative with the parts that are missing, but you have to perfectly match every single pixel of the original data that we know is correct. No exceptions. And that one simple rule is the key to getting a final image that isn't just a good guess, but is actually accurate. Okay, challenge number 3, and this is a big one, targeted editing. Anybody who's ever tried to edit a photo knows this pain. You want to use an AI to, say, change a horse into a zebra, but first, you got to sit there and manually draw a mask all the way around the horse. It is so tedious, and honestly, it's rarely perfect. This is where a method called DiffEdit comes in. And, okay, this is just brilliant. It figures out the mask for you, automatically. Here's how it works. It starts with the image, adds a little noise, and then it asks the AI 2 simple questions. First, what's the fastest way to clean this up and turn it back into a horse? And second, what's the fastest way to clean this up and turn it into a zebra? And wherever the answers to those two questions are the most different, well, that's exactly where the image needs to change. That difference is the mask. No more drawing by hand. It's incredible. And really, this is the dream, right? To move beyond just painting pixels by hand. The AI isn't just seeing colors anymore. It actually understands what you're asking for. It gets the meaning behind your request. Swap the horse for a zebra, and it isolates just that one change, leaving everything else untouched. It's a huge shift from the AI being just a tool to being a true collaborator. And that brings us to our fourth and final problem, speed. Let's face it, standard diffusion models are amazing, but they can be slow. We're talking hundreds of tiny little steps to get from a screen full of random noise to a beautiful, finished image. Here's the best way to think about it. Standard diffusion, that's like taking a slow, winding country road to get from point A to point B. But this new method, called rectified flow, well, that's like building a direct 6-lane expressway straight from one town to the other. It's just a fundamentally faster, more efficient way to get from noise to a finished image. So how in the world does the AI build this expressway? It uses this really clever training process called reflow. Imagine the AI starts by just finding any path to get there. Then it looks at the start and end points and basically says, okay, how can I make that trip just a little bit straighter? It trains a new model to do just that, and then it does it again and again and again, each time finding a more direct route, until it has basically paved a perfectly straight superhighway from that initial noise all the way to the final image. And here is the absolutely incredible payoff. By finding that perfectly straight path, rectified flow makes it possible to generate a stunning, high-quality image in one single step. We're talking about a jump in speed and efficiency that's hundreds of times faster. This completely changes the game for anything that needs to happen in real time. So let's wrap this up. 4 huge problems in AI image generation, and 4 really, really elegant solutions. We've got the Universal Translation Hub to solve rigidity and privacy. We've got hard data consistency for those messy restorations. We have automatic mask generation to get rid of tedious editing. And we have that straight path expressway to solve the problem of speed. This is truly the cutting edge, where AI isn't just getting more powerful, it's becoming so much more practical and intuitive for all of us to use. And that really brings us to the big final question, doesn't it? As these tools go from being kind of clunky and slow to being fast, precise, and almost seamless, the real question stops being about the technology. It becomes about us. When all the friction, all the tedious parts of creation just disappear, what's the next great creative barrier that we are going to break through? Something to think about. Thanks for joining me.